Okay, so now we go through a problem related to the things that we saw, and let's see what it is that they want us to do. Okay, let's see what it is. Remember what we're going to be doing here. First thing, as we go through this question, is to try and highlight important parts. We already have an idea in our mind that the last stage in all these four things is going to be vector sum and whatever. So we already have the procedure in our minds, but they might want you to go through certain steps, which is still going to be related to those steps, okay? And don't let it confuse you. Don't ever let it confuse you. So here we just have to find important details so that we draw a correct diagram when they want us to draw it. So here they're saying consider four charged particles. So point number one, we have four charged particles, okay? Denoted as P1, P2, P3, and P4. So we have P1 to P4. That's the names of these particles. And they are positioned at the corners of a square. So corners of a square with each side having, so they are positioned at corners. We are not just underlining. You are putting in your mind they are at the corners. So you have particles at the corners. If you're just putting a small diagram, these particles are at the corners of your square like that. This is how it is. These are where your particles are like. This is what it is like. I'm having a length of r. So that means the square, you know that all sides are the same. So we've just been told that these sides are r. So we know this is r, 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 and r. Now what is it? So we can underline length of r. The particles P1, P2, and P4 all carry the same positive charge. So P1, P2, P4 have the same positive charge. Now, what is the charge? What is the letter for charge? Q, right? So, what is the charge on particle 1 or on P1? It is Q1. Now, Q1, they said it has the same charge as charge on particle 2, which is Q2. And it has the same charge as charge on particle 4, which is Q4. So we are already knowing some more things here, some more details, that Q1 is equal to Q2, which is equal to Q4. Now, if P3 is situated at the corner diametrically opposite to P1. So P3 and P1 are diagonally separated like that. So if I put P1 here, my P3 will be in that corner. Okay, and now wherever I put the rest does not matter, because now I'm left with P2 and P4. I could put it like this: P2 and P4, or I could do this. I have my square again, okay, my square again, and I could now say P4 up here, P2 down here. Okay, it doesn't matter, but I should make sure that P1 and P3 are opposite, diametrically opposite, or diagonally separated. And I know that my square is r, r, r. So we could use both diagrams, and at the end we would get the same solution. Okay, now what is it? Create a diagram. So I've already shown you some diagrams, so we're going to make our diagram. We'll make it better now. We'll have particle here, particle there, particle there, and another particle there. I hope this is a square. Okay, it's like, remember that we join the centers, right? We join the centers of these guys. So it's going to be like that. So it's coming to the center, it goes straight to the center, and it's right straight. Then it goes down to the center straight again, and then this one goes straight again to the center. So this is what we have, and this is going to be r, 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 and r. Okay, now what did we say? We called this our P1, and we call this our P3, and we can call this P2, and we can call this P4. So it doesn't matter whatever you do. Sometimes you could have P4 up there, and when the working would look a bit different, but the answer will be the same, because P2 in this case in the other diagram will now be P4. So what you'll be getting for P2 in the other diagram would be called P4. Okay, but nothing is changing. Please, let me just get rid of this guy. Want to get rid of the keyboard. So what I'm going to do is maybe do this, then close it. All right, so now what we're going to do is would say I'm going to put diametric or diagonal line to P3. Now what else did they tell me? They told me that was it P1, P2, and P4? They have the same charge, and the charge is positive. Yes, P1, P2, and P4. So I'm going to go to P1, I put plus, P2 I put plus, P4 I put plus. That means the charge is just a positive value. They didn't say positive 1. Okay? They just said it's positive. So in this case, I could guess, okay, that the charge on P4 would be negative. If my answer is wrong, I'll see when we do it. So I'm guessing that the charge on P4 would be negative like that. Different from these other guys, okay? And once I have it like this, I'm done. So this is going to be my first diagram. Then what happens? What else do they then want? I've drawn the diagram of the situation. If you want to, you can find the length of this diagonal line between P1 and P3. And to find it, we see that this is a right angle triangle, so we are going to use Pythagoras, because if you want to find length and you have a right angle triangle, you use Pythagoras. Side opposite the right angle is your hypo, which is your C, okay, which is your C. You put C with a pencil, but the side you label, you can call it X, and then this one you'd call it A, and then this one you'd call it B. Now you know that Pythagoras says C squared is equal to A squared plus B squared. Now we replace those letters with the official ones. X squared is equal to, what is A? R squared, plus what is B? R again, so it'll be R squared. So we would say that X squared would be equal to R squared plus R squared will give you 2R squared. Okay, it's like 1B plus 1B. You get 2B's, right? 2. So it's going to be 2 of R squared. Then to get X, you take square root to the other side. You square root of 2R squared. Okay, and the square root, it would be X would be equal to the square root of 2 is just the square root of 2. And the square root of R squared is R. So you could write it as R root 2. Okay, like that. Okay, because the square root of R squared is just R. So you can bring it out because they are multiplying. You can't do it when they were adding. So it's because they're multiplying. So I can say it's R root 2. Or I could say X is equal to root 2 of R. Okay, though this one looks a bit weird writing it like that, root 2 of R. Okay, but R root 2 makes more sense. So that means I could say my X, okay, I could put the C somewhere here. Okay, say C. So my X is equal to R root 2. I'm done. Then I'll go to part B. I've done the situation. I have the situation. It's like that. Determine the charge. No, part B. Construct a free body diagram representing the forces acting on P1. So what is our particle of interest, class? P1. Our particle of interest is P1. So I'm going to circle it like that. Now, what did they say? Draw the free body diagram showing the particles, the forces acting on P1. All right, now we've put some things. We saw that when you have two charged particles like this, what do? They repel one another. So let's say this was my P1 and this was my P3. If I want to know this force on P1, it will be F3 on 1, okay? The force of particle 3 on particle 1, okay? And it will obviously be facing this side, okay? It will be facing away from P1 like that. So never forget, if your P3 is in this corner, then the force, and it has the same charge as P1, the force it is doing on P1 is push it away. So if I'm putting now, I have P1, and on top of P1, I have P2. So P2 is going to push P1 away downwards like that. So I know that is going to be. So if I put a free body diagram, I'm going to put a free body diagram. Let me, you put your P1 like this, positive, and you call P1. The force acting away on P1 would be forced by particle 2 on particle 1. And it'll be like that. Okay? Forced by particle 2 on particle 1. Free body diagram is just a diagram that shows all the forces acting on someone. Now, what is the other force? Particle 4 on particle 1. It's going to be pushing it away like that straight away. So I'm going to say the force, okay, let me put this P1 somewhere here. The force by particle 4 on particle 1, I'll say the force F41 is going to be facing away like that. Then what's the last one? Is the force by particle 3 on particle 1. Particle 3 is negatively charged, so it's pulling particle 1 to itself. So it's going to be slanted like that towards particle 3. And we can say it's the force of 3 on 1, like that. And we are done. Now, when I do my free body diagram, I can already put something here that is going to help me. And that is the components of particle 3-1. Now, what do I mean? Listen, every slanted line can be split into x and y. If you are a slanted or a diagonal line, it means you are doing both x and y at the same time. So that means I can split you into x. I can put one here along the x-axis. I could put a line, big line, and call this the x-axis. Then put another big line, okay, and call it the y-axis. Now this F31, because it's slanted, it has someone acting on the x, some part of it, and some part of it going up. It's doing two things at the same time. So I could know that I can resolve to get F31 in x. Why? Because it's a slanted force, so I can have F31 in x like that. And then again, along this y, somewhere here, when I take it to the y, I can resolve it into its parts. I can get F31, okay, in the y, and it's like that. That's done, okay? That would be the end of it. Now, one more thing is you'd want to put the angles, because to resolve, you'd need these angles. So we want to know what this angle is. If you want to put the diagram, if you want to put, you'd know that angle. And how do I know that angle? Well, this is an isosceles triangle because it has R here. Let me put yellow. It has R here and R there. So these two sides are the same, right? These two sides are equal, and the third one is not. So it's slightly different. Now, what do we know about an isosceles? The base angles, which is the angles where your two equal sides meet the third one. These two base angles, I'll call them, let's say I'll call them Z. This is Z, and this is Z again. These two base angles are the same. The two base angles of an isosceles triangle are the same. So this is 90 degrees. And then a triangle, we know it adds up to 180. So these two remaining, these Z's, are also going to be equal to 90 because they'll add this 90 and you get 180. So these two Z's are equal to 90. So you'd say 2Z is equal to 90 because there are two of them. That means Z will be equal to 90 over 2 and Z is equal to 45. Okay? So I already now know that